Today we're going to do a little more of an intermediate exponents question, which will be this one. Before we go into that, I was asked about a problem from the last video. What would happen if we did this about calculation in a different order? So if you recall, I had suggested first doing it this way. So the -1 flips the 1/27th, so it becomes 27. Then we take the cube root. That's what the 1/3 power means. So that becomes 3. Then we do 3 to the 4th, which is 81. So that was the suggested approach. What happens if we do it, let's say, this way? Well, first of all, certainly you don't want to raise this to the 4th power first, because that's really ugly. So at the very least, maybe you thought to do it this way. If you do it this way, you'll take the cube root of 1/27th, which will get you 1/3, because 1/3 times itself 3 times is 1/27th. Then you'll multiply 1/3 by itself 4 times to get 1/81. And then you will flip this to get the same 81. The reason I don't like doing this at the end is that you have to keep track of two numbers rather than flipping it right away and keeping track of just the 27. So doing it this way or doing the -1 first and then the 1/3 power, they're not too different, but it's a little easier to first flip this number by doing this first. So this method is not as good. All right, so today's question is, does 5 go into this number? In other words, is this divisible by 5? This vertical bar is shorthand notation for, is this divisible by that? So if I said 2, big vertical bar, 6, that's saying, does 2 go into 6? And the answer would be yes. If I said 5, vertical bar, 6, the answer would be no. 5 does not go evenly into 6. So this is just a lazy man's notation rather than saying, does 5 go? I don't want to write out the words. All right, so let's work with this expression here. So what in the world are we going to do? Keep in mind, these are tremendously large numbers, so we can't really tell whether 5 goes into this. What would help is if we had the prime factorization. So if I said, does 5 go into 2 times 5 to the 4th? You would say, of course, because there's 5s in here. But if I said, does 5 go into 4 plus 7? You're not sure because you first need to add these numbers. So our goal is to turn addition into multiplication. We want a prime factorization. This is not a prime factorization because it has a plus. If we can get this to be a time somehow, then we're there. So the key idea for today will be factoring. So first there's going to be 3 ways of doing this problem. There's going to be an easy way, a painful way number 1, and a painful way number 2. Let's do it the easy way first, and then you'll see what the other ways are. So the easy way is to break everything down. So what is an 8? It's a bunch of 2's. Specifically, it's 2 cubed. What's a 16? It's 2 to the 4th. So step 1 is you see what's the building block of these numbers, and it's a 2, so that's why I decided to go with 2. And then we have to apply the original extra powers. So this is what the problem becomes using our easy approach. So what's a power to a power? You multiply the powers. So it's 2 to the 30th plus 2 to the 28th. Okay, so believe it or not, this is already better because here the bases were different, here they're already the same. So now we're going to see, what do these two share? In other words, what's the greatest common factor of these two numbers? So we're going to be factoring out whatever that is. So this has 32's, this has 28, so they share 28 2's. So we're going to rewrite this as 2 to the 28th. In other words, we're going to pull this out of each of them. So we're going to get this. 2 to the 0th is just 1. So what have I done here? If you multiply this back in, so you're going to distribute it to both. 2 to the 28th times 2 squared is 2 to the 30th, and 2 to the 28th times 1 is 2 to the 28th. So these two numbers share 2 to the 28th, which was the GCF, greatest common factor. So we pulled it out. Why did we do that? Because remember, we were trying to get the plus to turn into a multiplication sign. And now we have it over here. Now you may say, but we still have a plus. Yes, but this part is really small and easy to calculate. So this is 2 to the 28th. 2 squared is 4 plus 1 is 5. So this is the prime factorization of that number. So what that means is, does 5 go into this? Of course it does, because we see a 5 is being multiplied here. So that's why through factoring, the key step in this the whole thing here going on is right here. We saw what they have in common, which is 2 to the 28th, and we pulled it out of each of them. So this is the ugly part. And now the part that was left over was just the 5. So that was the easy method. Now, the difficult method. You could alternatively try to make both of these into 16s, or you could try to make both of these into 8s. So you could say 8 is 16 to what power? Well, first we would take the 4th root to shrink this down to a 2, and then cube it to get back up to an 8. So again, the 4th root of 16 is 2. 2 cubed is 8. So what that means is we can replace the 8 with this. Now, why do we want to do this? Well, at least now we have the same base. The reason I call these the difficult methods is that I don't like working with these fractional powers and trying to figure out this conversion. So the easy method is break both of these down. The second method is, instead of changing the 8 to a 16, change the 16 to the 8. Again, this is doable, but why do you want this headache of a fractional power when you can just break both of these down into 2s? So that's the recommended method.